everyone. This is Tomali Haldar over here. I hope you people are doing well. Let's begin with the classes of education and we'll focus primarily on geography, UPSC CSE. So let's begin with that without any wasting of time. Okay, you can see that we have started with the class 11th geography topic, and the topic is interior of the earth. Now, what do we mean by the interior of the earth? Earth is a planet in the solar system, and the word interior over here will be, we will be exploring the various depths, various layers of the earth's surface while we go inside. Now, how is it possible to gauge the interior of the earth without even seeing it? Because it's not possible to survive at a very high temperature if we go deep below. So what are the ways by which we are going to explore the interior of the earth, and what does the interior of the earth has to offer it to us? Okay. The diagram itself is pretty explanatory. When I talk about the interior of the earth, that means we are going to explore the inner layers of the earth's surface. It's no longer limited on the outer surface of the earth's surface. But how is it possible to gauge the interior of the earth when there is tremendously high temperature and tremendously high pressure? Imagine me standing in the interior of the earth and watching whatever is happening inside so that I can teach you in the class. But will I be alive? No, I won't be alive. But there have been scientists who have explored various ways by which they can gauge about the interior of the earth, and that is what we are going to do today. So our knowledge about the interior of the earth is very limited, but whatever we have gathered is possible because of the two things, or the two sources of evidence. We call it the direct evidence, and another evidence we call the indirect evidence. Direct evidences in this particular case regarding the explanation of the interior of the earth refers to those type of evidences which we are able to see with our naked eye without exploring deep below the interior of the earth. We are just able to see with the naked eye. That is the phenomena that is taking place on the earth's crust or on the earth's surface, which will then help us to understand what is happening in the interior of the earth without going inside. That is the direct evidence. Indirect evidence, on the other hand, refers to those type of evidences which we cannot just rely by looking whatever phenomena is occurring on the earth's surface, but we have to look inside the interior of the earth. But how is that possible? That is what we are going to do today. And it is the indirect source which is the most reliable source of the earth. It is not the direct evidences. Okay, so over here you can see one image I have given. In this image you can see certain molten materials are coming out. This molten material which is coming out is what we call lava, not magma. That is the basic difference between magma and lava. The molten material which is inside the interior of the earth, that is called magma. When it comes out, it is called lava. So here you can see from this diagram that the lava is coming out. There is a volcanic eruption. So you can see that the volcanic eruption is taking place. You don't have to go inside the mountain and see that the volcanic eruption is taking place. It is coming out on the earth. So when the volcanic material is coming out on the interior of the earth, it will solidify because outside the temperature is quite less, but in the interior, I can say the temperature must be very high, which has led to the melting of the material for which the molten material are trying to come out. Since I can see it with the help of the naked eye, so that is why my volcanic eruption over here becomes a direct source of evidence for understanding what is the temperature pressure condition in the interior of the earth. That is the direct evidence. The next one is the indirect evidence, and that is what we are going to go at in details because that is the most important source of information. The word is written study of the seismic waves. Seismic waves are nothing but the earthquake waves. When the earth is shaking or when there is vibration of the earth's surface, certain waves are being released. Certain waves are being released from the interior of the earth, which travel here and there. And it is with the help of those waves which helps us to identify what is the condition in the interior of the earth. It is very important before we go into details. It's very important to explore what are the various categories of the earthquake waves, because on the basis of these categories only, we will identify what is the condition in the interior of the earth, as I have been repetitively emphasizing on. Earthquake waves or the seismic waves are primarily of two types, body waves and surface waves. Just go by the word. What can be the meaning? Surface means limited on the surface of the earth. So surface waves refers to those type of earthquake waves which are limited on the surface of the earth or which are moving only along the surface of the earth. There is no movement in the interior of the earth. But body waves, on the other hand, refers to those type of seismic waves which are traveling from the interior of the earth and then it is going to the outside of the earth's surface. Let us consider the shape of the earth. Let's say this is the earth. The earth's equator is bulged out. And the earth is not a circular, it is elliptical in shape.
The Earth's equator is bulged out. Equator is 0 degree and 90 degree is the poles, and it is very narrow, and you can see for yourself at the polar region. Let's say, for example, let's say you people, this is the surface of the Earth, and one of you is standing on the surface of the Earth. This is the Earth's interior from where the earthquake waves move out. Now, the point, let's say, for example, this is the point of the origin of the earthquake. Let's say this is the point of the origin of the earthquake. This point of origin of the earthquake is what we call focus. The earthquake is originating from this particular point. The earthquake is originating from this particular point. So when it is originating from this particular point, the earthquake waves are being sent. I have drawn it with the help of the yellow color. The earthquake waves or the seismic waves are being sent. When these earthquake waves travel all along the interior of the earth and then it reaches the surface of the earth, we call these body waves. Whereas on the other hand, this is another scenario. You are standing on the surface of the earth and there is an interior of the earth which I'm drawing it with a red color, and this is again the focus of the earthquake. In this case, what happens? The earthquake waves or the seismic waves which are coming up, they tend to focus. Sometimes what happens, they tend to focus on the surface of the earth without disturbing the interior of the earth. So when it is trying to limit itself to the surface of the earth, we then call it the surface waves. So this is the broad framework. We are going to focus more on the body waves and not on the surface waves in this scenario. Why? Because you can see that the body wave is traveling throughout the interior of the earth, and we are more focused on the interior of the earth. So body waves in this case becomes more important. Body waves are of two categories: P or the primary waves, S or the secondary waves, and surface waves are of two categories: love waves or Rayleigh waves. We are going to focus on primary waves and secondary waves in this case. The first, we need to understand the different characteristics, because with the help of this characteristics only we can identify what is the nature in the interior of the earth, whether one layer is solid or whether one layer is liquid. I will come to this in details in the successive slides. The nature of the primary wave is, it is very important to remember that it can travel through all the medium, and by medium I mean whether it's a solid medium, whether it's a liquid medium, or whether it's a gaseous medium. It can travel through any medium. The only thing is that primary waves travel with a very high velocity in the solid medium. The moment it enters liquid medium, its velocity drops, but it is still there. It is still there. Secondary waves, on the other hand, the basic characteristic is that it travels only through the solid medium. As soon as it approaches any liquid medium, it will disappear. So technically, if I compare primary waves and secondary waves, primary wave is more not powerful. Primary waves travel with very high velocity than secondary wave. In this case, I have not mentioned the velocity, but over here I am saying primary waves travel at a velocity of 8 km per second, whereas secondary waves travel at half the velocity of primary wave, that is 4 km per second. So the basic characteristic is primary wave will travel through all the medium, but it will travel with a very high velocity in solid. Its velocity drops in liquid. Whereas on the other hand, secondary waves travel only through solid. It is not very friendly with liquid, or it has enmity with liquid, so it disappears in liquid medium. Before we jump into the details, just have a broad overview as to how the shape of the earth can look like depending on the shape of the egg. However, this theory doesn't prove entirely true the more we explore it. The egg has three layers: its shell, its white portion, and the yolk portion. The shell is the outside layer, so the outside layer of the earth is also called the crust. The white portion in this particular egg is a subsurface layer between the crust and the yolk, lying in between that. So in the case of earth, it becomes mantle. And the innermost layer of the egg is called the yolk, which is equal to the innermost layer of the earth, called the core. So this is the shape of the earth. This is the interior of the earth. This is the interior of the earth. Let's begin from the beginning. From the surface of the earth, from the surface of the earth up till 100 kilometer, you will see two divisions, that is Sayal and Saima. Sayal and Saima are nothing but the two layers falling on the earth's crust. Crust is the outer layer of the earth's surface, that which we are able to see. So Sayal is one part of the crust, Saima is another part of the crust. Go by the word Sayal. It comprises two things: Si plus Al, that means silica and aluminium. Saima, again two words: silica and magnesium. Sayal is nothing but the continent or the continental crust. Saima is the oceanic crust. Now you might have the question that why is Saima below the Sayal? That means how is the ocean below the continent and how can I even see it? When ma'am is telling that crust is the outer layer of the earth, we should be able to see it. But in this diagram, it feels like Sima is below Sayal. I won't be able to see it. Now let's equate this with visiting the coastal area. When you visit the coastal area, or when you go for tourism, or when you are a tourist in a particular coastal area, you stay in a hotel and then you go to the beach area for bathing purposes. So when you stay in a hotel, that hotel is a part of your continental crust because it is built on the land. The moment you go to the water body, it is a part of the oceanic crust. Now imagine you are staying in a hotel and there is an ocean. Is the ocean below the hotel or above the hotel? Obviously, the ocean is below the hotel. The only reason being, ocean is comprised of those materials, that is magnesium specifically, which makes it more heavier than the Sayal. So technically, Sima comes under the Sayal, but it is very much the part of the Earth's crust, and the the existence or the thickness of the entire crust is from the surface of the Earth up till the 100 km towards the interior of the Earth. Towards the interior of the Earth, Sayal is the continental crust, which is most importantly comprised of granitic rocks or the granite. Sima, on the other hand, is the oceanic crust comprised of the basaltic rocks. Okay. Now, in Sayal, obviously we get the continents, the land, and on the land we have the mountains, plateaus, and the hills. So what happens? For the mountains which are standing on the Earth's surface, they need some portion also below it in order to support it. Why am I saying this? I hope you people have watched the movie of Titanic. Why did the people could not see the iceberg that was there in front of them? Because a very small portion was floating on the surface of the Earth, but a very giant portion was floating inside the surface of the Earth. Why is it so? Because for every one part of the iceberg to float on the Earth's surface, 9 part has to be below it. Like for example, if this is the part of the glacier which is there on the surface of the ocean, then this much amount, look at the thickness of my thumb, this much amount of the glacier should be below it so as to support this, right? So last point, it is telling that crust extends up to 60 km below the mountains. What is the meaning of this? Let's say this is a mountain. That means if this is the mountain, this much amount of the crust should be below the mountain to support what is standing on the surface of the earth. Again, if this is the plateau is obviously of lower elevation than the mountain, then a very less portion of the crust should be below the plateau in order to support it. That is only what it is written over here. But the major focus should be on the crust is divided into 2 parts and what are the variations and what rocks they contain. Now, after crust, you can see there is a portion called mantle, and after mantle, you can see there is a portion called core. Now, why is it important to study the 3 layers? Because as we move on to the different layers, we can understand whether each layer is solid or liquid in nature, whether each layer is having a high temperature or a low temperature, whether one layer is more denser than the other layer. One thing which you are going to find constantly throughout this explanation is that the more you go towards the interior of the earth, the more is the density of the rocks, or more bhari, or more heavier the rocks are. Temperature will vary, and the rocks, whether it is solid or liquid, that will also vary, which we will discuss. But the moment you go towards the inner core, or the moment you go towards the interior of the earth, pressure goes on increasing, and that is a constant factor. Okay. Now, the rocks in both Sayal and Sima, they exist in solid state. Ocean is liquid, but the ocean bed on which the water is there, that ocean bed in itself is rocky in nature, which is containing basaltic rock. Also, as I told you that the interior of the earth, how do we know it, whether it's solid or liquid? The knowledge comes from the indirect evidence, that is the seismic wave. So how can I know that Sayal and Sima is solid in nature? One another source will be the indirect evidence, that is the seismic wave. When the seismologists, that means the people who are studying the seismic waves, when they studied this with the help of the primary waves and secondary waves, they came to a conclusion that both the primary wave and both the primary and the secondary wave, they are passing very smoothly through Sayal and Sima. Thus, they were of the conclusion that both Sayal and Sima are comprised of solid rocks. Same diagram will pop up, but different layers description will come up. Now, from 100 kilometer to 2,900 kilometer comes up yet another layer, which we call the mantle. If you remember, this is equal to the egg white. If I go back, egg white, that means the middle portion. From 100 kilometer to 410 kilometer. I deliberately or intentionally did not write 410 kilometer for you to know that where the 410 kilometer will be. Obviously, it will be at this point between 100 kilometer and 2900 kilometer. So from 100 kilometer to 410 kilometer lies another layer which we call the upper mantle. We are moving from crust to mantle. We are moving from crust to mantle. At SIMA, can I see that the crust is ending? And also, can I say that the portion of mantle is beginning? So I can also say that the crust is ending, mantle is starting. That means there is a discontinuity. Crust is discontinuous. It is not prolonging towards the interior of the earth. At one point, it is ending. At one point, it is pausing itself. So the point where it is pausing itself, or the layer between the SIMA and the upper mantle, or the transition layer between SIMA and the upper mantle, is what we call the Mohorovicic discontinuity. Because it's a discontinuous layer. SIMA is not extending into the upper mantle. After SIMA, which is a part of the crust, another layer is coming up, which we call the mantle. Okay. And just like every human being has a nickname, so upper mantle is also having its nickname. So upper mantle is also called the asthenosphere. And the thickness of the asthenosphere is from 100 kilometer to 410 kilometer. What the seismologists found out was that upper mantle is semi-solid in nature. That means half solid, half liquid. Why half solid and half liquid? Because we are going towards the interior of the earth, temperature is increasing, pressure is increasing. But if I compare it with the rest of the other innermost layer, then the upper mantle's temperature is much lower than that of the outer core. Because the more I go towards the interior of the earth, over there the temperature will rise though. But at the upper mantle, the temperature is not that severe in comparison to that of inner core. So in upper mantle, rocks are very moody. They either behave in solid or they behave in liquid. And remember one thing, both the Sial and SIMA, they are floating. They are floating on the upper mantle. Upper mantle is giving that energy to the Sial and SIMA to go here and there. Why do we have earthquake? This is because both the Sial, which is situated on the SIMA, is floating on the upper mantle. It is, if this is the upper mantle, if this is the upper mantle, this is the SIMA. And on SIMA comes up the Sial, because the SIMA is carrying the Sial. So this is the Sial, this is the SIMA, and my hand is upper mantle. Upper mantle semi-solid. Heat is being provided to the SIMA. SIMA is carrying the Sial. So SIMA is also moving wherever the heat is going. Wherever it is moving, for example, if another continent comes, it will strike. If it strikes, it will lead to earthquake. It can lead to volcanic eruption. So that is how the plate tectonics come into account. Movement of the plates or movement of oceanic crust or continental crust. It is when the upper mantle is providing the energy for this move. Consider the fourth point. It is written upper mantle is in state of semi-solid. It is rigid and brittle due to lower temperature and less pressure. Brittle means it is having a low temperature and the rocks at upper mantle will have a tendency to break. Why? For example, when you put chocolate in a freezer, it will experience a very cold temperature. The moment you take it out, it won't melt in your mouth. You will tend to break it. If you can break it, that means the chocolate is brittle. Upper mantle rocks are brittle because they are having a lower temperature in comparison to that of the innermost. Now, the very crucial part is lower mantle. Acha, before I go over to the lower mantle, one more thing which I forgot to say. In upper mantle, why is it semi-solid? One thing to be told that the rocks exist in semi-solid stage and there is plate tectonics. But I need indirect evidence. How will I know? Because I'm not going to the interior of the earth. What the seismologists found out was that they saw that both the primary and the secondary waves were facing a reduction in velocity in the upper mantle. Why? And then they came to a conclusion, Acha, P and S waves are facing a reduction in velocity. That means the rocks must not be solid in nature. They must be moving more towards the liquid, for which the P and S waves are also experiencing reduction in velocity. Then moving over to upper mantle to lower mantle. Lower mantle is extending from 410 kilometer to 2900 kilometer. That is the extent of the lower mantle. Now, this is very crucial. I told you that the more we go towards the interior of the earth, temperature is supposed to increase. Now, this becomes very ulta in lower mantle's concept. What the seismologists found out with the help of indirect evidence was that as soon as the P and S wave were moving from upper mantle to lower mantle, both P and S wave, they faced an increase in the velocity. Now, you might ask, how can that happen? The only reason it can happen and the only source of answer will be that the rocks must exist in solid stage, for which the P and S waves are facing an increase in the velocity. That is the conclusion. So in lower mantle, rocks are solid in nature. The only reason is the P and S waves, they face an increase in the velocity. In the fifth point, you will come across a word. It is lower mantle. It is plastic in nature. Plastic nature of the rock means the rock has the ability to deform. You can bend the rock. How can you bend a rock? In lower mantle, remember one, the rocks are existing in solid state along with the high temperature, but the rocks are not breaking. In upper mantle, the rocks are breaking because its temperature is quite less in comparison to the lower mantle. But in lower mantle, what is happening? The rocks are existing in solid state along with the high temperature. That high temperature is allowing the rock to deform, to bend, but it is not breaking. Okay. And also in comparison to the upper mantle, another reason can be the pressure is more in the lower mantle. So the more I put pressure on anything, the gap within that rock will disappear and it will become more coherent, more compact. So lower mantle technically becomes more solid than the upper. The last layer of the earth, or the innermost layer of the earth, is what we call the core. Again, just like crust was divided into two parts, mantle was divided into two parts, we are again going to divide the core into two parts. We are again moving from one region to another region. That means from a mantle to core. That means there is a break, there is a discontinuity. So the transition line between mantle and core is what we call the Gutenberg discontinuity. And the Gutenberg discontinuity was discovered by a seismologist called Benno Gutenberg. B-E-N-O, Benno Gutenberg. Outer core, the extension is from 2900 km till 5100 km. Another tricky part comes over here. Let's begin inner core and then I'll say the outer core. Inner core, what is happening? Inner core is the lowermost layer of the earth. Temperature is tremendously high, and over there the pressure will be very high. And where the pressure is more, the gap within the rocks tend to disappear. They become more compact. They become more solid in nature. They become more dense. So technically, density is more at the inner core, or density is highest at the inner core, and the rocks are very solid in nature at inner core, along with the high temperature and high pressure. That is very understandable. And the inner core is extending from 5,100 kilometers till 6,378 kilometers. What the seismologists found out was that the outer core is liquid in nature. This is a tremendously surprising thing. Then how come outer core can become solid, liquid in nature when it is tremendously towards the interior of the earth? And again, we are relying on the indirect evidence. What the seismologists found out was that as the P and S wave entered into the lower mantle, they faced an increase in the velocity. The moment they moved from lower mantle to the outer core, they experienced a drop in the velocity. Remember one thing, P moves through solid very happily. The moment it goes to liquid, its velocity drops, but it is still there. What happens to the secondary waves? They travel through solid very happily. The moment they see liquid, they disappear. What seismologists found out in the outer core was that the primary waves were moving with a very low velocity in the outer core. But the secondary waves, they disappeared. They totally disappeared. And with the help of that, they concluded that outer core must be liquid in nature. What can be another explanation? As I told you, that rocks exist in solid stage in the inner core. Now imagine when the rocks are tending or trying to become solid in nature, what is happening when the rocks are becoming more solid? They are becoming more coherent, they are becoming more compact because of the increasing pressure. The heat, I'm giving a yellow color, the heat which is there in the gaps of the rocks, that is trying to come out and go here and there. Heat, it obviously is more lighter. Anything being lighter will tend to rise up. So the moment it is rising up, you can see it is interacting with the outer core. So more heat is there in the outer core, which is liquefying the area, which is melting that area. So your outer core becomes liquid in nature. Why? Because the moment the rocks tend to solidify in the inner core, heat escapes, and the heat which then escapes tend to come up. The moment it comes up, it interacts with the material in the outer core, melts it, thus making the outer core liquid in nature. So you have two things. So you have one thing only. The indirect evidence is that in the outer core, the P waves face a reduction in velocity, and the S waves, they completely disappear. So the portion of the outer core is called the shadow zone. The portion of the outer core is called the shadow zone. And the portion of the upper mantle, where there is a reduction in velocity in both the P and the S wave, we call it a low velocity zone. Go by the word. Half of the answer lies in the word itself. This is the difference between the Mohorovicic and the Gutenberg discontinuity. Mohorovicic, you can see it's lying between mantle and crust. Gutenberg discontinuity, it lies between mantle and the core. The last thing which is very important I would like to conclude is that why did we study the interior of the earth? I know it's a portion of the syllabus we have to study for the job preparation and all, but it also gives us an understanding that what is actually going on in the interior of the earth. We are always interested in the exterior of the earth. Why not on the interior of the earth? Because the moment you're having an earthquake, that means something is happening internally, which is putting an impact on the outside surface, or which is putting an impact on the external situation. And that is very much related to the idea of plate tectonics. Plate tectonics is nothing but related to the movement of the continental crust or the basaltic crust or the oceanic crust. And as I told you, upper mantle is responsible for the plate tectonics because it is providing that energy, providing that heat to the crust lying on it. So the if I understand that somewhere earthquake is taking place, somewhere volcanic eruption is taking place, immediately I would know that something gadbad or disturbing is happening in upper mantle for which such problem is occurring, right? And the second part is, all this while we knew that the interior of the earth temperature is more, pressure is more. So the more we go towards the interior of the earth, every layer will be solid in nature. But no, it is not happening. One layer is solid, another layer is liquid, another layer is solid, another layer is liquid. So there is a juxtaposition of the things that is happening. And that is what the second point is. It gives us a detailed and an accurate insight as to what actually the interior of the earth is. Okay. I hope the session was interesting. Please let me know. Give me the feedback if I need to improve on it. Thank you.